Okay, so today we are going to continue the discussion about planes. So last time we talked about finding the edge view and the true shape, so I'll review that. And then today all we're going to do is add the slope to that. And in addition to the slope, we're going to talk about the direction that it slopes down as well. So let's just, before I get into the slope stuff, let me just refresh your memory on figuring out the edge views and the true shapes. So I'll just go through one or two of these again real quick. You don't have to do this with me. You guys did this already with me last time, but I just want to review since it's been a couple days. So again, my whole point of finding a true shape is I first need an edge view. To get an edge view, I need a true length line. If I have a true length line, I can go perpendicular to that. That will give me a point view of that line, and then the entire plane will be an edge view. So when I have something, I want to first figure out if I already have true length lines. In this case, I do. JL is parallel to the horizontal plane, so JL is a true length up here. JK is parallel to the front, so JK is true length down here. However, we're going to measure the slope today. So I don't want to come off perpendicular to JK. I want to do it in an auxiliary elevation view, because similar to lines, we can only measure slope in elevation views. So knowing that, I'm going to come off of the top here. And I goofed up my snap there, I think. There we go. And then project these across. Pull my offsets from down below. J and L are the same. That's what's going to give me a point view. And then K is the one further down. And again, I don't care if you actually place points on these or if you just draw on the lines, that's fine too. All right. So there is my edge view. So then from the edge view to find the true shape, then we created a hinge parallel to the edge view. Obviously, I'm not doing any labeling as I go here, just for our little example, but don't forget to label. And then on my offsetting, looks like I've got L as the closest, then K, and then J.
How did you get your command, your current command you'll pop up by your...
Say that again, Blaine. I'm sorry. How did I get what?
The current command or whatever will pop up by your...
Oh, yes. That's this button right down here, dynamic input. So I usually work with it off, but if you like it, you can turn it on. And yeah, I didn't even notice that I had that on there. But yeah, if it's on and you're staring at your command line, you won't see it go into your command line. It just goes next to your mouse. Good question. Okay, so for my points then, I'll have a point here, and one here. And then this would be my true shape. Try that again. There we go. Put these into the object layer. And then, of course, we are going to label TS for true shape. No other labels necessary. So that's kind of where we were last time. So today we're going to talk about the slope, which is, after doing it with lines and after setting up this view, is actually fairly easy. The good news is I'm going to ask you for the slope as an angle. And as you know, that was kind of the easiest one. You didn't have to lay out the parallel or perpendicular lines. So you just have to find the angle. The additional thing that we're going to have to do, though, is we're going to give a general quadrant direction that it's sloping down towards. So either north, south, east, west, or northwest, southeast, northwest, northeast. We're not going to do the exact so many degrees west of north or anything like that. Just a general direction that it's sloping down. So again, after I've got my true length line, now in mine I was able to use one of the edges, but you might have to create that horizontal strike line in the front and then project up into the horizontal plane to get your true length. Then again, we're going to go, actually let me hop past that one. Then we're going to go to find our edge view, and then of course we'll find our true length as well. But then our slope is just simply going to be the angle between the horizontal plane and our line. So similar to when we did this with lines, you don't have to draw any little line here. You can use the hinge. So if I go back to my example, the slope then of this plane is going to be between the edge view and the horizontal plane. So I have a 43-degree slope. And it's just going to be, even though we're kind of telling it which way it's going down, remember a plane technically in mathematics goes all directions forever. So it doesn't really make sense to put a negative or a positive on it. It just slopes at a 43-degree angle. But then the other part is, which direction does it slope down towards? So to figure that out, what we want to do is we want to take a look at the true length strike line. So remember, the true length strike line is a point view over in this view. And so that basically means that if you want to think of this as kind of a hinge, it's sloping perpendicular to this true length line. So if this is a point over here, then it slopes perpendicular to this true length strike line. So if you draw a line, and in a lot of cases you won't have to draw a line, you can kind of figure it out by looking, but if you draw a line perpendicular to the true length strike line, this will tell you your direction. Now if I put a little compass over it, then the answer is going to be, and ignore the answer I've already got up here, but I've got one of two choices. This line, if it slopes this way down, is southwest, right? Or it's going northeast. So it's going one of those two directions. And the correct answer is, which direction is it sloping down? So as I look over here at this view, B is the lowest point. It slopes as it goes down towards B. And I can confirm that in the front view. B is the lowest point, right? So that means it slopes down as you go towards B. Since B is right here in the top view, that means it slopes down as it moves towards the southwest. And again, I'm not going to ask you for exactly how many degrees west of south or anything like that. Just a general 45-degree slope angle towards the southwest is what we're looking for. So let's just take a look at one more quick example. I'm not going to completely redo this one, but I'll take a look at the ones that I've already done. So here's the one earlier. I created a horizontal strike line. And let me just remind you, when you create the horizontal strike line, then I'm just going to use a ray to project up. W is on line XY, or yeah, XY. So don't just stop here at XZ, it goes up to XY. But then I construct my true length strike line. So my slope angle then is going to be the angle between this line and the hinge. So I've got 50 degrees. And then the direction, I'll just draw a line out in space perpendicular to this strike line. So obviously if I hold my mouse over it, it's either going to go down towards the southwest or up towards the northeast, or I should say down towards the northeast. So if we take a look at what is the lowest point is Y. So this plane slopes down towards Y. Where's Y up here? Y is right here. So that means it slopes down as it goes towards Y, which is a northeast direction. So the correct way to display this then would be 50 degrees northeast.
How did you find the true length strike line? That was...
Initially on this one?
Yeah.
Yeah, let me back up and show you guys that again. So to find the true length strike line, since I don't already have one, an edge that is that, then I just want to create a horizontal line in this front view. So again, it could be something like this, but if I do it that way, I've got two edges to project. So I'm usually trying to find a corner that I could use, such as that Z. Take it straight over. It lies on XY, so I'll take it up to XY and then back to Z. So that'll be your true length strike line. And then that's what this hinge is perpendicular to, of course. Good question. So as far as the exercises today, just got a couple of them for you where you're going to find the edge view and the true shapes, and then also add in the slope as the new thing. So planes 3 and 4. So with planes 3, here's a plane with 4 corners. So if I'm constructing a true length strike line in the top view, I'm probably either going to draw a line from A straight over or from C straight over and take that intersection up. So either way would be appropriate. But we want that true length strike line up here and then hinge off of there so that our edge view will be sloped away from the horizontal plane in an auxiliary elevation. So you'll find your edge view, you'll find your true shape and label it, and then for your slope, just use the text tool and write it out to the side. Whatever degrees, whatever direction.
Sloped away from?
So whichever, it's the direction it's sloping down. So yeah, if that's your strike, so you're saying that, let me do this again here. So it looks like you did this line, right?
Yeah.
And then where that hits a D, then this would be your true length strike line. So my direction, I don't know my slope angle yet, but what I do know is that B is the lowest point. So it's going to slope down as it goes to the northwest because B is up here. So if I drew a line perpendicular to my true length strike line, it's going either southeast or northwest. Northwest is the direction it's traveling down to B. So it will be some angle northwest. If any of you guys struggle with that, just call me over when you're working on it and I'll try and help you see it through. And then planes 4 is really the same instructions. They used to be the same drawing, but I thought they were crowded, so I split them up. So planes 4. Here's another part. This time you've got a true length, couple of true length edges. You just got to make sure you go off the one that gives you an auxiliary elevation, not an auxiliary incline. So again, edge view, true shape, and then slope. So just those 2 for today. So let me know as you guys run into any questions.